In a turbocharged engine, boost control is very important for both performance and your engine's longevity. Too little boost, you're not going to make much power. Too much boost, you're going to blow your engine. So today we're going to talk about how do you control boost. The most common way to control boost is with a device called a wastegate. A wastegate is a valve that allows the engine's exhaust gas to bypass the turbo. With the exhaust gas bypassing the turbo, your turbine doesn't have as much stuff to spin and your boost will go down. When the wastegate's closed, all the exhaust gas goes through the turbine and it speeds up, you make more boost. So basically it's a pneumatic device that helps maintain a set boost level. So we're going to talk about wastegate tech today, internal wastegates and external wastegates. And what a better way to talk about external wastegates than introduce Garrett Vent Wastegate new line of external wastegates. So when it comes to wastegates, the most common wastegate, at least on the OEM side, is the internal wastegate. Almost all of your cars that come with a factory turbocharger has an internal wastegate. This is a turbo from a Subaru STI, for example. An internal wastegate is called an internal wastegate because it's built into the turbo itself, in the turbine housing, in fact. There's like a little flapper valve. Now this flapper valve controls the flow through a passage inside the turbine housing. This is the end that bolts to the engine. The exhaust gas comes here, flows through the turbine housing and comes out through the turbine. Now the wastegate is a passage that bypasses this exhaust flow right here, and it has this flapper valve. When the wastegate opens, this valve flaps open and the exhaust gas just bypasses around the turbine and goes into the exhaust. Now the way it works is there's this dashpot diaphragm here. This little hose goes to your intake manifold. There's a spring that's calibrated to give a certain boost pressure and an arm that opens and closes the flapper. So let's say this sucker, just for ease of understanding, this spring has 10 pounds of resistance. So when the boost pressure in your manifold goes above 10 pounds, the pressure will start to overcome the spring and it'll open the flapper, allowing the gas to bypass the turbine, and your boost will go down. And this way, more or less, it'll keep your boost at 10 psi. Now the internal wastegate, some of the advantages are it's nice and compact, it's simple, it doesn't add clutter to your engine compartment, and it can be pretty reliable. One of the disadvantages to the internal wastegate is that the valve's pretty small. There isn't much room to make a bigger valve. And if you're going for higher power levels than stock, you might run into what's called boost creep. Boost creep is when this valve doesn't flow enough to slow the turbine down enough. And what happens in that case is you overboost. So let's say you're set at 10 pounds. The engine is putting out a lot more flow because it's making more power. And this doesn't flow enough to slow the turbo enough to get down to your set boost. So your turbo will start to overboost and you could damage your engine. Your engine might not be built to take the additional power that the additional boost pressure creates. Your fuel might not be good enough to prevent detonation. Your fuel system might not have enough capacity, etc. So that's one of the downsides. These internal wastegates are usually sized so they have a valve that's just about enough for the stock power level. So sometimes even if you do like full bolt-ons, you might start getting boost creep with the internal wastegate. Another disadvantage of the internal wastegate is when the valve starts opening, the exhaust gas blasts right across your turbine face. That creates extra back pressure that your engine isn't going to like. It also screws up how efficient your turbine is because you're creating turbulence right at its exit, and this causes more turbo lag and a loss of power. So, I mean, you can kind of see how when this valve starts to crack, it's going to squirt like high pressure exhaust gas right across the face of the turbine. That's one of the reasons why anytime you have an application that makes significant power, it's usually best to go to an external wastegate. Now Garrett was nice enough to lend us some of their external wastegates. They just came out with these, and they're nice enough to give a cutaway version to us so we can do a little point around to show how these work. Now an external wastegate is just like what it sounds like. It's external to the turbo. It's a whole separate unit that stands away from the turbo, and it controls boost in about the same manner. The external wastegates have bigger valves. When you have a nicely sized big valve, your control loop for your boost pressure is tighter. So the bigger valve is going to be cycling at a higher rate, so it's going to keep your boost pressure more consistent. When you have an internal wastegate that's being pushed to the limit, the boost is going to swing and fluctuate more. But with a properly sized external wastegate, the boost will stay more constant because of this. Another advantage to an external wastegate is it can actually produce more power. So let's say you have an internal wastegate that's pushed to the max, it's wide open, it's blasting across the turbine face, and it's struggling to keep the boost down. That's going to have more back pressure than a properly sized larger wastegate valve that's flowing easily within its capacity. So you're not going to be building up any excessive back pressure in the exhaust manifold. So Garrett makes three sizes of wastegates. The biggest one, the 50 millimeter, flows over 40 kilograms per second. This is enough to control a little over 1,000 horsepower worth of boost. The 40 millimeter flows about 17 kilograms per second. This is an ideal size for around 400 horsepower. And the 45 millimeter flows in the low 20s, and this is like right in the middle of 500-600 horsepower is kind of the sweet spot. If your engine makes more power, you can run two wastegates and double up your flow. So it's all scalable. With the internal wastegate, what it is what it is, and you kind of stuck there. But with externals, you can add more wastegates to scale it up and get as much flow as you need. So to get as much flow as possible in a compact package, Garrett uses CFD to design all the housings. Now CFD is called Computational Fluid Dynamics, and it's a really powerful analytic tool which allows the engineers to do flow simulations before the part is actually built. So a lot of the shape, you can see it's a nice rounded onion looking shape with like a flare around the valve, is designed specifically to get the flow from the valve, change the direction, and send it out the exhaust. There's like a lot of subtle differences in the shape that can make a big difference. For instance, you might notice that the 50 millimeter wastegate has a slight upward cant to it. This was determined to aid quite a bit in flow without making the footprint much bigger. CFD discovered that, and here we are. So heat control is critical for external wastegates. Time attack cars have sealed up engine compartments and complicated exhaust manifolds. There's not very much airflow around the turbo and wastegate, so the heat can get really bad. Drift cars sit there idling and heat soaking, then they run full speed for about a minute and then sit for minutes waiting for the judge to make their decision. It all heat soaks while it's idling, and sometimes they gotta go again and again. Bonneville cars, the engine's sealed up for aerodynamic purposes and they run flat out for more than a minute. They also have corrosive fuel. All these things are brutal on the wastegate. So one of the things that's really important is heat control in an external wastegate, and the Garrett wastegate has a lot of advanced features to do just that. First off, let's talk about the diaphragm itself. Now, in an external wastegate, you have the spring. The spring holds the valve closed, And you have the diaphragm. The diaphragm is referenced from boost pressure. The boost pressure pushes against the diaphragm opposing the spring. So like, let's say the spring is rated at 10 pounds. When you get more than 10 psi in here, the diaphragm will overcome the spring and allow the valve to open. Now, a lot of cheap wastegates, the diaphragm is made out of rubber. At high temperatures, the rubber melts and gets a hole in it, and you lose all wastegate control and you lose all your boost pressure. Garrett has addressed this by using a silicone rubber that's reinforced with Nomex. Now, Nomex is the same fiber that race suits are made out of, and fire pilots' uniforms and firefighters' uniforms. It's a really heat-resistant, fire-resistant material. So to reinforce the diaphragm, that's probably one of the best things. The diaphragm housing is set off from the valve body through spacers to minimize contact, so heat can't get conducted from the housing into the diaphragm housing too easily. There's spacers here, and that creates an air gap. There's also a stainless steel heat shield that prevents heat from radiating up and getting into the diaphragm housing. There's also cooling fins around the bottom that gives additional area to dissipate heat. Perhaps the best feature of all is the diaphragm housing has the option to be liquid cooled. Now, liquid cooling is a great thing. In Garrett's testing, it can reduce the temperature that the diaphragm sees by 50%. How this is done is you can get some of the coolant that normally goes through your throttle body or maybe the center section of your turbo, and then route it through the wastegate housing first. So it's pretty simple, makes a big difference, and I wish we had this in our Bonneville and some of our time attack cars. It would have really helped and probably eliminated any wastegate problems that we had. Now, some other wastegates have this as an option, but Garrett has this as a standard feature, and I think that's pretty great. Now, we've also had problems with the valve itself sticking in various cars. Like we were running one drift car on an ethanol fuel that had some oxygenating additives in it, and these were pretty corrosive, and they also made like a rough scale. The scale built up on the valve stem and made the valve stick open, and we lost boost. Now, Garrett's addressed this in a couple of different ways. First, the valve guide bushing is made out of Nitronic 60. Now, this is a pretty slippery, tough metal that's super heat resistant, and it's dimensionally stable at high heat. I'm not sure what it's made out of, but the name sure sounds cool. Garrett also has a high temperature stainless valve, and the valve stem is coated with an anti-stick high temperature coating. Now, this coating is so slick, it helps prevent the scale from building up, and it should be highly effective in preventing sticking no matter what kind of fuel's being run. The valve seat goes into the base of the housing here and seals. This is really cool because this is a service part, so when the wastegate gets old, and if there's anything going on, which is highly unlikely, but just in case, this can be replaced. What I have seen in some other turbos is the valve seat warps, especially like maybe the fabricator is welding on the flange, and some of the heat from welding gets into the seat and warps it, so the wastegate never does work too well. With the Garrett seat, it's a serviceable, removable part. You can get a brand new one if it ever stops sealing very well, and it is easily serviceable. Now, one of the things is don't forget this sucker, and don't forget to put it in when you're working on your wastegate. Don't ask us how we know about this kind of stuff, but you forget this thing, the wastegate doesn't work, and you won't make boost. The valve housing itself is made out of high-temp stainless, so you're not going to see any corrosion or anything going there. And what's cool is every single part in the Garrett wastegate is available individually as a service part. So you know, like in between seasons, if you want to freshen up your wastegate and they do wear out, you can get any part. Like I would probably recommend changing the diaphragm, maybe the seat and the valve, like after a tough season. I'd at least inspect it and see if there's any erosion, but if there is, it's all available as a service part. The Garrett Wastegate can be adjusted for a native pressure from anywhere from 3 to 23 pounds with these various springs. It comes with a 1 bar or 14.5 pound spring pre-installed, but the wastegate also comes with these other springs. Now these go from 3 pounds to 23 pounds. What I think is really cool is all the other wastegate manufacturers make you buy these, but they come with the Garrett, so you have all this flexibility of adjustment. Now when I say native pressure, that's the pressure that you would obtain if you just bolted this on your car. Now it's not the pressure that you have to run. You can run a boost controller and increase that native pressure by up to 100%. So that's not necessarily the pressure, but it's the pressure where the wastegate will be working the easiest without any kind of boost control assistance. Other nice features about the Garrett Wastegate is it's held in with V-band clamps. The V-band clamps have one bolt to release and makes the wastegate quick release, makes it easy to service. So I just finished talking about how the Garrett Wastegate's so wonderful and so heat resistant, and it's a new wastegate in the market. How do I know that this thing is going to perform like what I'm talking about? Well, one of the advantages that Garrett has is that they're an OEM supplier, and if you've ever been to Garrett, man, they have like huge labs that are like probably 30,000 square feet. And they have all kinds of badass stuff like hot gas test stands and shaker rigs and all kinds of stuff. So they can do full durability testing and OEM level validation. And this wastegate has been subject to the whole gamut of tests, anything from hot gas, maximum temperature durability, vibration testing, torture testing being cycled while at maximum temperature and being vibrated. Anything you can imagine, this wastegate has had to pass all these stringent tests. Another advantage of the Garrett Wastegate is that it's super low hysteresis. Now hysteresis is a big fancy sounding engineering word that we use whenever we don't know what we're talking about. Well, that's not true, but hysteresis is any kind of delay or lag in a control operation. So if you say a wastegate is low hysteresis, what that's really saying in normal English is it's really fast responding. A control input by your boost controller will equal a control movement by your valve very quickly. Now, low hysteresis is from having a low as possible mass in the valve and all the little control pieces within the wastegate and having the best ratio of valve size to diaphragm size. And with Garrett's advanced engineering and computer simulation, they've been able to achieve the lowest hysteresis of any external wastegate in the industry. So Garrett tested the valve's hysteresis before and after their torture durability testing, and they found that the hysteresis was almost exactly the same before and after the torture testing. This speaks highly for the gate's durability as well. Another cool feature is that Garrett paid attention to the aftermarket, and they made their gate so it is compatible with anything that has a tile type flange. And almost every other wastegate has like little tile adapters, so almost everything can be upgraded to a Garrett gate. Another cool feature that the Garrett gate has is it has 3 control ports on the bottom of the diaphragm housing and 2 ports on the top. This gives maximum flexibility when you mount it and how everything's directional. So that just makes it even easier to convert over to a Garrett wastegate. Finally, for all you guys that are into style, the Garrett wastegate comes in 4 different colors. Red, of course, silver, blue, and black. One thing that you should be aware of when you're putting an external wastegate on the car is the mounting position. Now, the ideal place for an external wastegate is close to the turbo, and you want to have it at 45 degrees in the direction of flow. Now, a lot of guys will just be lazy and they'll put the wastegate in some position, like maybe in one runner or something, or far away from the turbo, and they'll have it at 90 degrees. Well, the wastegate will be really a lot less effective. For instance, even if you have an ideally placed wastegate, and if you mount it 90 degrees to the flow instead of 45, the wastegate will flow 50% less. So it's really worth it to pay attention to how you mount the wastegate. Now, the wastegate discharge is also important. You probably want to mount that at 45 degrees, at least 18 inches away from the turbine. If you have it blasting 90 degrees into the exhaust flow, that's going to be a flow impedance. It'll add turbulence and cause more back pressure. If you have it too close to the turbine, it'll interfere with your turbine flow, make the turbo more laggy, and really cause a lot of back pressure. So the rule of thumb is 18 inches away from the turbine at least, further is better, and reintroduce that flow at least 45 degrees, hopefully in the nice merge collector kind of arrangement. So if you like this video and you want to see more of me and this stupid co-starring fly, be sure to subscribe to our channel. Also go to MotoIQ.com, check out all our sweet articles. We have literally thousands of articles with all kinds of tech for all kinds of cars. And don't forget to go to our social media, check out our Facebook and our Instagram. So until next time, I hope you look at more of our videos and digest more tech.